There we go. Quick. Let's get through this so you can work. What I want to do, I want to look quickly at one problem. We'll look at how to graph or choose the graph of a circle, right? So this is the problem I want to look at. We want to find what circle is this, and I think I've got this one pulled up here somewhere. I better. Okay, so what if we're trying to find this circle, right? It's really hard or impossible to tell by looking at that equation. It doesn't tell us much, right? So let's look at this backwards for just a second. Let's look at what if we're going to take the reverse of that question and say, okay, here's a circle. How do we describe it? What are the defining characteristics of that circle?
Infinite.
Well, okay, true. I mean, it's infinite. It's blue. There are lots of things we could say about it. But mathematically, what are the qualities or the characteristics of that circle that define it?
Diameter, radius.
Okay, radius would be good, right?
Circumference.
And radius tells us the size, but we need to know something else about it. Say it again. We need to know, I mean, where it is, right? In order for us to identify a circle, we have to know where it is and how big it is. And how big it is for a circle, that's just one number, the radius, right? That's all we need to tell how big the circle is. So we could measure the radius pretty easily. Right, if we just go, let's see, where's the center? Looks like it's right about there. That line up there's the top and the bottom. There's the left and the right. Everybody agree?
Yes.
And the radius looks like it is 1, 2, 3, 4, 5, 6, 7. The other thing we need though is the location, and so we could just find maybe the coordinates of the center, right? So the center is the one unique point on the circle. All the other points are, sort of interchangeable, right? This one is over 2 and down 3. Okay? Everybody agree? Those are if I knew that information, I could go find this circle, right? So I need to do the same stuff with this one then. I need to somehow I need to extract from that equation, I need to know what the center of the circle is, what the coordinates are, and I need to know what the radius of the circle is, right? Okay. How are we going to do that?
X minus h squared plus y minus k squared equals r.
Okay, good. So what we need to do is we need to take this equation of the circle and we need to put it into standard form, right? So we need to write it in the form x minus h squared plus y minus k squared equals r squared, right? So h, k, and r, those we spent a lot of time last Thursday talking about this stuff. Those are the parameters, right, of the circle. They define it. They describe it completely. All right, so to do that, it looks like I have to get my x's, all the x terms, I have to rearrange those in such a way that they're going to look like, I'm going to turn them into a perfect square, right? So let's take the x terms, and we got to build something like this out, right? So what do I have? Well, I've got an x squared plus 4x plus, we'll leave room for a space. We're going to need to add some number to that to create a perfect square. Trinomial, right? Little factor. And then got to do the same thing for the y's, right? I've got to get a perfect square, right? Y minus something squared. So let's take all of the y terms. I got to do the same thing with those. And then on the other side, well, I'm just going to have some number, right? So I'm going to start off with this negative 36. I'm just going to add 36 to both sides just to get rid of that, right? Get that on the other side. Okay, so this is stuff we've done quite a bit of, right? We're just going to complete the square. So let's take care of the green stuff, the x's. So what's going to be, Caitlin, what's going to be the number that we're going to combine with x? Based on those first two terms, we know the number that has to go with x. It's got to be 2. Good. Because it's going to be half of this 4, isn't it? Right? Okay. Now we already know then, what's h? No. What's h? We're just gonna compare this to that first term.
16.
No, now look now, it's x minus h squared. Well, here's
Another
x
two?
plus 2 squared, so we've got to compare. What's the number that's being subtracted from x inside this square?
2.
Negative 2, right? Because it's got to be the opposite of that sign. X plus 2 is the same as x minus what? Negative 2, right? So this tells us right here that h equals negative 2. Well, that's one down, 2 to go, right? We got one of the parameters. Now, to get that, though, we're not quite finished. To get that, we needed to add a number up here to create the perfect square trinomial. So what's that going to be? Good. It's good. We have to square that 2, don't we? So we're going to have to add 4 to both sides. Okay. Now we're done with the x's. Let's look at the y's. Okay, so from the first two terms here, from the y squared minus 6y, we already know what's the number we're going to combine with y. Maisie, what are we going to do here with this? What number has to go down there with y? It is. So what's half of that? Negative 3. Okay, so that tells us then we know what's k going to equal. Just 3, right? K is just the number that's being subtracted. All we're going to do is compare the standard form to what we're getting down here and see, well, what's taking the place of that k? Well, 3 is, right? So that's in math, we just call that inspection. We're just going to inspect the equation and look to see what did we plug in for k to get our result. Well, we plugged in a 3, didn't we? So k equals 3. So already we know the coordinates of the center are what? Negative 2, 3. That's where the center of the circle is located. Okay, but now to get this perfect square, we had to build the perfect square trinomial. What what number did we have to add? Okay, now negative 3 squared is what? Positive 9. That's always going to be positive, isn't it? Because we're squaring it. So I got to add 9 to both sides. And so the only thing we're missing over here is just our r squared. Well, there it is. Whatever we get. 36 plus 4 is 40, plus 9 is 49. Okay, so now compare that to the standard form. 49 is equal to what? R squared. So if r squared equals 49, what's r? 7. We got it, right? That's it. So we know the radius, we know the coordinates of the center, so let's go find this. Negative 2, 3, radius of 7, right? So which one's that going to be? Negative 2, 3, that's where our center needs to be, right? It's over in quadrant 2. So obviously this circle's not right. That one's not going to work. No good, no good, no good. Ooh, that's a possibility. Let's try that out. So negative 2, not quite, it's close. Not quite, we got to keep going.
Yes.
That looks promising right there. Let's try it. Negative 2, positive 3, that's in the center. Let's test the radius and see if the radius is 7. 1, 2, 3, 4, 5, 6, 7. We got it. That's it.
Yes.
Right? Make sense?
Yes.
Okay, see how we did that? Go. Well, I'm assuming you want to work today, try to get this stuff done. Say it again. Yes, you may.